Action. All right. Do you guys remember what a factor is?
Nope.
Nope. Nope. Yes. Nope. Nope. Yep. Nope. Okay. For example, what are the factors of 10?
Oh, that thing.
2 and 5. 10 and 1. And that's it. Those are 4 factors of 10. Factors are things that multiply into something else. This chapter is called factoring, but we're not doing much with factoring normal numbers. We're doing a little bit today. Mostly we're factoring polynomials. What's a polynomial?
Something special.
It's that thing we did last chapter, but that's the polynomials. Okay, so it's a new kind of factoring. We'll get to that in a second. Really, there's 3 main ways of factoring that we will be learning this chapter, but today we're only learning the first way of factoring. And I call it take stuff out. The book calls it factoring common monomials, which is confusing. So, let's start with greatest common factors. Actually, I might just start that in the lesson. Yeah, we'll just go. We should just go. Mark, set, go. Number 1. How do we find the GCF of 45 and 75?
Greatest common.
Yeah, what does GCF mean? Greatest common factor. It means the biggest thing that can multiply into both of them. Do you guys have a guess before? 5 is a good guess, but it's not right. 25 doesn't go into 45.
No.
15 is correct. Okay, here's how you do it. Here's how you do it. Well, you could make a list of all the factors and then just circle the biggest one. You guys remember doing that in like 7th grade? Here's the other way to do it. Do the tree.
Yes. Oh.
We actually did do this a little bit in 7th grade
Do
too.
we have to show?
Or 8th grade.
Yeah, we did.
A little bit, yeah. Yeah, go ahead and show your work on these. What goes into 75? How many quarters and 75 cents? 30. Okay. So, you remember how we wrote the answers on these? This is 3 times 3 times 5, so it's 3 squared times 5.
Yes.
And this is 3 times 5 times 5, so it's 3 times 5 squared. All the bottom branches. You only use the bottom branch. You only use the primes. This is called prime factorization, factor tree.
Isn't that the...
How many were you?
You only use the bottom branches.
26.
26. Okay, here goes. Are you listening? This is the magic part. It's not the answer. Britton already said the answer, and I said yes. But he was guessing, so this is how you know for sure. To find the greatest common factor, use the least of each kind of prime.
So
To find the greatest common factor, you can only use the primes they have in common, basically. So what's the least amount of 3's?
3.
1, 3. What's the least amount of 5's? 1, 5. The least amount of 3's, looking at these, comparing, is 1. The least amount of 5's is 1. So I'm using 1. 3 times 5 is 15. 15 is all they have in common.
So do we have
What?
to show all that work to just know that that's what they have in common?
You didn't know that, you were guessing that.
Well, I knew
So
it's
yes, show your work.
45 and 7.
Yes, show your work. Okay, what if this one had 7 on it?
Don't you just put the...
Okay, what's the least of my 7's?
Just
0.
None. So I would not use a 7. So the answer would not change.
Oh,
The least of my 7's is no 7's. So I wouldn't use a 7.
I'm hurt.
So if it's not in either, in one, both
Right.
of them, then it's.
The least,
It's
yeah.
gotta be a hairy sign.
No, that's just the first part.
That's...
It actually goes faster after 24x plus and 32xy. So now we're getting some letters involved.
Hey.
Okay. Yeah, I probably would let you guys cheat on this one. What goes in 24 and 32? 8. The biggest, I don't know if I can explain this, but the biggest possible answer is going to be the difference between these two. Because if you count by 8s, 8, 16, 24, the biggest the gap could be is 8. Anyway. 8 is the
You
greatest
can
common
just
factor.
subtract.
Okay, so I'm going to use the same, for the letters, I'm going to say the same thing. That only works on some problems. Well, it doesn't work on every problem. Didn't work on the last problem, for example. For the x's, I'm going to ask the same question. To find the greatest common factor, what's the least of my x's? 1x. That's a tie, but they both have 1.
So it's just 8x?
What's the least of my y's?
None.
None. So I'm not going to put any y's.
Wow.
The answer's in
Okay, why is this the greatest common factor? Because this is the biggest thing that you can still multiply something to get both of these. Like, what could we multiply 8x by to get 24x? 3. What could we multiply this by to turn it into 32xy? 4y. So this goes into both of them. It's the biggest thing that goes into both of them. Anyway, that's the answer. Number 5.
I'm 4.
Just letters. What?
What about 4? I'm 455.
Okay. What goes into 7 and 15?
Nothing.
This is number 4. Well, 1 goes into everything.
So you just say relatively prime.
Yes, those are called relatively prime. If you look at the directions,
Oh, right.
that is the only problem like that on the entire assignment.
So right.
Relatively prime. They wrote it in the directions. That doesn't mean they're prime. Like 15 is not prime because 5 times 3. It means comparing to each other. That's what relatively means. They don't have anything that they share besides 1. Number 5, x squared y cubed y squared.
It's x squared. Y
Okay, so here's the question again. The greatest common factor, what's the least of my x's?
3 and 2.
What's the least of my x's? X squared. So I'm going to use that. What's the least of my y's?
Squared.
Y squared. So I'm going to use that. You can multiply this by something to get both of these. It's the biggest thing that can go into both.
Wow. So you're not
Keep
going
on
to make us
putting
do
a
the
bunch of
entire
space
tree
things,
thing,
the evens and the
right?
odds, just to get.
Huh?
You're not going to make us do the tree thing, are you?
Well, let's see. For number 2,
Talk about
No.
let's see.
No.
it. It's third.
No.
Yeah, I guess it won't.
What goes into 2? 7, 11.
Okay, number 7. This is new. This is different. This is
new.
so what we did on 1 through 6 is just kind of a reminder of what factors are. Number 7 is more like what we were doing this chapter. This is a polynomial. It's a binomial, right?
Yeah.
Okay, we are factoring. We're breaking it up into the factors. Like factors of 10 are 5 and 2. We're saying what is the factors of this whole polynomial.
1 and 3.
Okay. The first way of factoring, which we're learning today, is called take stuff out. This is the very official title.
TSO.
Okay.
So,
My question is, what can both of these terms be divided by? What can I take out of both of these?
3.
At 3, right? No, how about the letters?
1.
No. It's like the letters don't have any factors in common. Like if they both had an x, we could take an x out. Okay, so the greatest common factor of both of these terms is just 3. So what I'm going to do is I'm going to put 3 parentheses, and then what's left if I divided 3 out of both of these?
X
One.
and Y.
y
Okay.
x plus 1.
X plus y. Kind of like reverse distributive property. It's like instead of multiplying the 3 out, we're taking the 3 out.
Would the answer be 3xy?
Okay, what would happen if I distributed that out?
3x plus 3y.
Go back to that, right? So we're not doing that though, because otherwise we'd just be writing the answer to the question.
So
I mean, we'd be writing the answer as the question.
That's the answer.
So this is the answer. 3 times x plus y, those are factors. They multiply together to equal the original. That's why it's called factoring. These factors multiply that to that.
On A with B.
So we're not simplifying, we're not putting stuff together like we usually do, like last chapter. We're actually breaking it apart, because some kinds of problems you need to do that to solve. Alright, so far so good?
So So on 8 would it be like 8 cubed, parentheses x plus y?
On 8, what comes out of both of those?
A.
A parentheses
Oh, so you don't.
x plus y.
Okay.
Okay, 9, what comes out of both of those? 8x minus 32y.
8.
8 does. And you gotta, to get it full credit, you gotta take the biggest thing out. Like, you could say 4 comes out of both of these. Both these are divisible by 4. But 8 is the biggest, the greatest common factor. What's left after I divide an
X
8?
minus. No. 4x.
8x divided by 8 is x. 32y divided by 8 is
Minus 4y.
4y. If you multiply it back together, it should go back to the original.
This is your,
That's
is it like
check
you
it.
find the biggest thing they're both divisible by,
Yes,
and then
yes.
do stuff?
The greatest common factor, 8, divide it out, see what's
I
left.
understand.
About 10. What goes into both of those?
15.
15.
15. So,
So
it'd be
15's on the
x plus
outside of
2.
parentheses.
X plus
Okay, 11. A squared minus a. We'll use this one. People will miss, but it's an odd, so you should.
A.
Okay, what goes into both of them?
2.
A. What's left after I divide an a out?
A.
Okay, that's where we get it wrong.
A minus.
What's a divided by a? 1.
Fine.
That was confusing.
Well, we just did a chapter on divide. Remember, like 3x squared divided by 3x squared is 1, not nothing. You
Yeah.
remember talking about that?
I just never said it like that.
I don't. We didn't get it in our brains, maybe, but we talked about it.
What about 12?
What about 13? 13 is, oh, I lied. X squared y plus wz. What did I lie about? Okay, what goes into both of those?
Nothing.
Nothing.
Nothing. So guess what I'm going to put?
Prime.
Well, okay.
Prime.
Yeah, relatively prime would be comparing two different things. This is one polynomial, so we're just going to put prime.
That's crazy.
I think, let me see if there's any even primes. Okay, there is one.
Which one?
This is top secret.
Top secret.
Does anything go into both of these? Can we take anything out of both of these? No.
No.
So we can't do it, so we just put prime. It's kind of like 7. What goes into 7? Besides 1 and 7, nothing. So you just stop. That's prime. 15.
Would that be 80?
7x squared. It's a 3-term. Time to panic.
7.
49 x1
Yeah, it is 7.
plus 28 y.
What's big?
That's 7.
No.
Yeah.
7. How about the letters? Do any letters go into all of them?
Y.
No, not all of them.
Not all of them. It's got to be all of them. Y works in these two, but not this one. X works in these two, but not this one. So just 7 is all we can do. I think on this first section you can only take out one thing. Yeah. Okay, what's left after I divide this by 7?
Squared.
X squared
Netted negative
minus 49 divided by 7.
Yeah.
7xy plus 28 divided by 7.
4.
4 y squared.
This isn't so bad.
Don't jinx it, Sam. Like,
You're
you have a habit of
Too
doing
late.
it.
It's
I do
done.
have.
Right when Sam says this is not too bad, that's when it's about to change.
Yeah.
6a squared.
He's the Grim Reaper.
Is that the cream?
6.
Does 6 go into 28? No, because I wrote it wrong. It's supposed to be 48.
And I was like, wait a minute.
Okay,
Oh.
but actually let me put that back. That's kind of important because they haven't given us one of those yet. What would that actually be?
28 to A over
2.
3. 6.
2.
2. Okay, and that one all we could take out was a 2, but that's not the actual problem, so don't write that down. Alright, now what can we take out? 6. Okay, what's left?
A squared.
48 48 divided by 6 minus 24 divided by 6.
8.
Already?
4.
Goes to my desk actually. 24 divided by 6 is 4, close parentheses.
He's so relaxed.
Did I write this assignment on the board? Probably not.
No, you didn't.
We are doing
Monkey.
page
He's the monkey.
406, 1 through 26.
I want to be monkey.
Found out which one was prime.
What?
Will it be 18?
Yeah. Which one? 18.
Okay, 19. Okay, we're in the new section. What do you think that means?
Something is changing.
Something's changing.
I feel it in the wind.
As predicted by the bad omen of Sam's. This is easy. Okay. What can we take out of, let's start with the numbers. What can we take out of both of those?
3.
3.
A
Okay.
and B.
Now the letters. How many A's can we take out?
1.
1. Another way to ask it, the way I was saying it earlier, what's the least amount of A's? 1A.
Or 0.
What's the least amount of B's between these two? 1B. So you can take out a 3, an A, and a B.
So
Magic.
What's left after I divide this first
2AB
term
plus
by 3AB?
2.
2
B squared.
A squared divided by A, A.
Plus
B,
squared.
B divided by B, 1.
Well, 1.
1, but it's gone. Okay. Plus 3 divided by 3,
Plus B.
gone. A divided by A, gone. B squared divided by B,
1.
Or B.
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 Why would we put?
Feel okay.
Oh no.
Is that talk crap?
How can I check and see if this is right?
The back of
I still won't get it.
Well, if it was an even, how would I do it though?
I want to be sad. I want Godzilla, but I want to be like.
Plug it in the computer.
it.
So
Calm one.
you could use distributive property and see if it goes back to that. You good? There. All right.
How much do we monkey?
21. 91. Is 91 a prime? Probably not.
Oh
Yeah, 91's prime, is it not?
Oh
91 and 13.
Well, 91 is not in our times table. That doesn't mean it's a prime.
Divided by 3, divided by 11.
Okay, what might go into both of these?
3.
7.
Well, not a lot goes into 13, right? 13 and 1. You don't take out 1 though, that's like taking out nothing. So does 13 go to 91?
Yes.
How many times?
7.
So we don't know that, you just have to plug it in your calculator. What's 91 divided by 13? 7. Or you can work it out by hand, right? Like that's gonna happen. 13 comes out of both of those. How many A's can I take out?
2.
2. They both have at least A squared.
So it's
How many B's can I take out?
B squared.
1.
B,
1.
Like I said.
Good job.
What's left after I take it out, after I divide it out?
7 AB.
91 divided by 13 was 7. Somebody plugged it in. A cubed divided by A squared.
1
A. B squared divided by B.
B.
Plus 13 divided by 13.
1.
Gone. A squared divided by A squared.
Gone.
Gone. B divided by B.
Gone. So nothing.
And
Well, 1.
1.
Wait a minute.
Sam's
Well, you have
curse.
no
The
idea
curse
what's
of
going
Sam.
on?
I forgot about books though.
Oh.
The curse of Sam.
Well,
Mm-hmm.
This is going to be easy.
This is kind of easy.
Will?
Well,
Will,
Notice I
easy
haven't
stuff.
said that yet.
Are you done?
You said you have no idea whether or not.
you just never know. So just don't
Oh,
say it.
23 is prime.
Well, I mean,
Is
we're
23
doing this with
prime?
the rest
Yes.
of the paper, so.
Yeah, it is actually.
X,
Yeah.
Y, Z, 14
Yeah,
and
it
15.
definitely.
Does anything go into 14, 15?
No.
No. Do they have any letters in common?
No.
Okay, so it's prime.
Sam's a
Who
genius.
could have predicted?
Oh, we're on the last
Who's
one.
been messing up? Really? It's been saying.
Yeah. I thought we should go
I
back.
probably should have done a couple more.
No, let's go back to
No,
the
I
It didn't have to go so hard.
We just go to the
Wrong
emails
photos.
together.
It's written on the board. It can never be taken back.
Yep.
A long time.
Right.
Ooh, ever since
We should do the
it
emails
was number
together.
one. It was-
Yeah, that would be.
Yeah, this assignment is pretty easy if you know your times tables. If not, it's gonna
It
take a
is.
lot more work.
If not 4 and X. 4X. Yeah,
Yeah,
4X.
what goes in 12 and 16?
4X.
4.
4x.
How many X's can we take out?
3X.
One. One comes out of both of them. The least of the X's is 1X. How many Y's can we take out?
None.
None. So that'll be outside the parentheses.
3X squared.
What's 12 divided by 4? 3.
X
X cubed divided by X.
squared.
Minus. What's 16 divided by 4? X divided by X.
Gone.
Gone.
Mhm.
Y squared divided
Y
by
squared.
nothing. Y squared. Okay.
Wow. This isn't so bad. I said it.
Um, usually people will panic on number 24 because of the pi. We'll just guys figure it out.
23. I actually do like 5.
Me too.